Now we're going to wrap up the 56th part of this course with basic trigonometry, and this is section 7.4. So some of you may have seen this before, some of you may have not, and we're just going to really cover some basic trigonometric definitions so that you will be ready for 216 for those of you who are going to go on to 216. The trigonometric functions for what are called acute angles. So we have these, what are trigonometric functions, and this is what we'll call an acute standard angle in the standard position. Now what that means is that we have a right triangle, like we just discussed right triangles, and here is a little square that tells us that it's a right triangle. And we see we're going to define an angle, that's what this means, a little angle A. And these are usually written in the big letters. A is an angle, B represents the angle, and C represents here the right angle of this triangle. We want to look at these definitions. We have the sine, and the sine of this angle means that we have the opposite, which we look at here is the opposite, which is across from this angle, and that's y over the hypotenuse, which we called r here. Now the cosine, here may be a new word, adjacent. So the cosine is the adjacent, which means the one that's right next door to the angle, over the hypotenuse. And the tangent is the opposite, meaning here's the opposite, over the adjacent side, which is x, so that's going to be y over x. Now, of course, these have actually reciprocals. So the reciprocal of the tangent is what's called the cotangent. That means if the tangent is y over x, the cotangent is x over y. Similarly, for the sine, we have what's called the cosecant. And the cosecant of A, if the sine is the opposite over the hypotenuse, then the cosecant is the hypotenuse over the opposite, which is its reciprocal. And similarly for the cosine, we have the secant, where the secant is the hypotenuse over the adjacent, and that is the reciprocal of cosine. Now, how are we going to remember all of this? This is sort of hard to remember. I bumped into this, and this one actually helped me, so this old hippie is actually going to help me out. So we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, meaning the one next door, and tangent is opposite over adjacent. It turns out that some old hippie, here's our hippie, our old hippie over here, came a-hoppin', and he's hopping through our apartment. So we have sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Now, many people have learned in school another mnemonic. I would always confuse the O with the A in pronouncing it, so I preferred the old hippie myself, but some learned Soka Toa, the old Indian chief, and it's fine however you want to remember it, whether you want to use one of these mnemonics or a mnemonic that you have learned or a mnemonic you have made up, that is fine. Here in example 1, we're going to find the values of sine A, cosine A, and tangent A in a right triangle shown. So here's our right triangle, and here are our angles A, B, and C is our right triangle. And here we have our sides, our legs, one's 48, another leg is 20, and then our hypotenuse is 52. So we're going to use our definitions of sine, cosine, and tangent based on however you want to remember the definitions. We start off with sine, and we have the sine of A, so here's A because we're talking about A. And the definition of sine would be opposite, which is the 20, over the hypotenuse, which is 52. Our definition for cosine is the adjacent side. So here, the adjacent means it's right next door to the angle. So that's 48. And then over the hypotenuse. And then finally, our tangent of A, which is the opposite, 20 over the adjacent, which is 48. Now for one that's a little bit more challenging, we have triangle A, B, and C, and we have the right triangle is C, 90 degrees, and 90 degrees, and the sides, which I said usually are small letters, and the angles are big letters. So the sides, one of the sides is 6, and one of the sides is 10, as shown in the figure here. So we have here 6 is going to be A, and this is how we label it. 6 is going to be A. We don't know what B is because B, usually we define the sides as opposite of the angles in small letters. So the length of B is opposite angle B. The length of A is opposite angle A, and the length of C, of course, is the right angle, is 10. So here's how we define it. A is 6. We say that A is equal to 6 because that's opposite the angle A, and that means that C, since C is the right angle, that means 10 is our hypotenuse. So we use our Pythagorean theorem, and we solve for B. We see that C squared, which is 100, minus 36, because when we solve for B, we have to subtract it. So that's going to be 6 squared is 36, so that gives us 64, and so we get 8. So now we're going to look for the trigonometric functions. So I'll do the first one completely, where I have the sine of A, and as we said, the sine of A is going to be opposite over hypotenuse, so that's 6 over 10, and then I'll reduce it to 3 over 5 just for the heck of it. And then if we're going to do its inverse, well, all we have to do, its inverse is cosecant A, and all we have to do is just turn this upside down. Going through all 6 of them, we can see that we've learned and figured out that the 6 trigonometric functions of A, we're going to use the small a, the one that's opposite the angle, is 6. The one that's adjacent to the angle is 8, and then our hypotenuse will be 10. So we proceed, and we have the sine is equal to A over C, which is 6 over 10, and then its reciprocal, cosecant, is 10 over 6. And cosine is the adjacent over hypotenuse, 8 over 10, and then its reciprocal, secant, is 10 over 8. And then finally, tangent is the opposite over adjacent, or 6 over 10, and its reciprocal, cotangent, is B over A, or 8 over 10. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye for now.